Om Sri Guru Basavalingaya Namah. Today we shall do some numericals based on lenses, prism, etc. Now, first question is, what is the refractive index of material of a plano-convex lens if radius of curvature plano-convex lens, if radius of curvatures of the convex surfaces are 10 centimeter each and focal length of the lens is 30 centimeter. Now, what is given? We have got a convex lens with us. Its radius of curvature says R1, radius of curvature of this face says R2. Refractive index of the material says N. Then, ask to determine what is the value of N. N means refractive index is how much? Of lens, radius of curvatures, both the radius are given to be equal to 10 centimeter, and focal length is given as 30 centimeter. Now we have to use the sign convention. Suppose a ray is incident like this. For this surface, radius will be that side, that is R1 will be this side. For this face, R1 will be, R2 will be this side. So now, here if we take this distance and direction of incident ray are same. So therefore, what we do? We take R1 as plus 10 and opposite side, what we do? We take minus, because the surface is like this, ray will be ray is traveling like this, we have to measure the distance in this manner. So we get it on F equal to 30 centimeter. Now we know R2 is minus 10 centimeter. We know we got formula n minus 1 by R1 minus 1 by R2 is the formula. This will become 1 by F means 1 by 30 equal to n is asked minus 1 by 10 minus of 10 means 1 by minus 10. Now it will become 1 by 30 is equal to n minus 1. This will become 1 by 10 plus 1 by 10. 1 by 30 equal to, we will be getting here n minus 1, 10 will be the LCM, 1 plus 1 will be getting. Now it can be written as 1 by 30 equal to n minus 1, 2 divided by 10. 2 divided by 10. Now, what happened? This can be written as 1 by 30 into 10 by 2 equal to n minus 1. This is what here. Now this will get cancelled. We'll be getting here 1 divided by 6 equal to n minus 1. If we transfer that one here, we get 1 by 6 plus 1 equal to n n will be equal to 7 divided by 6, 6 or n equal to 1 point here 1.0101 1 6 or 167 we get it on. So this will be the answer here 1.167. Now let's go for next question. Next question. A concave lens of glass, comma, refractive index 1.5 has both surfaces of same radius of curvature, and same radius of curvature R. First, on immersing in a medium of refractive index 1.75, it will behave as dash dash dash. Now here, if you remember in the last class we have done one thing, but that question is slightly different from this. Here what is given, a concave lens is there with us. And refractive index of this one, we'll take that one as n. N equal to 1.5. N equal to 1.5 has both surfaces of same radius of curvature R. So this also has got same radius of curvature. So here, if you don't write this also, will be okay. Now, initially here, nothing is mentioned, means air is there. Was given on immersing in a medium of refractive index 1.75. So now, this lens is immersed in one medium. This refractive index will be same as initial one. We get around this one as N2. N1 equal to 1.75. 1.75. It will behave as what type of lens is asked. So now we'll take F1 as equal to F, F2 equal to how much is asked. Since it is a concave lens, we'll take that one as minus F, F1 as minus F, and F2 equal to how much. Based on that, we can fill the gap there. Now, we know this, that 1 by F equal to N minus 1, 1 by R1 minus 1 by R2 is the relation we have got when one medium is there. And when two mediums are there, it will be N2 by N1 minus 1, 1 by R1 minus 1 divided by R2. 1 by R2. Now, we will use here that also, that in the beginning we got F1 as F, later we got F as F2 is how much we have to calculate. We will divide the two. We get on 1 by F1 divided by 1 by F2 equal to N minus 1, 1 by R1 minus 1 by R2 whole divided by N2 by N1 minus 1, 1 by R1 minus 1 by R2. These two things cancel. It will become F2 divided by F1 equal to n minus 1 whole divided by n2 by n minus 1. Now, we will put the data, known data, we can run f2 by minus f equal to n is 1.5 minus 1 whole divided by here n2 is 1.5 by 1.75 minus 1. This will take here 1 0, remove the decimal point. Now we can cut this one, 25 7 ja, 25 6 ja, 25 6 ja. So this will become f2 divided by minus f equal to, we can run minus, well only plus 0.5 divided by, here 7 will be the LCM and 6 minus 7 will be getting there. So 7 will be the LCM, 6 minus 7, and now it can be written as f2 equal to 0.5 into minus f divided by minus 1 divided by 7. Minus 1 by 7, 7 comes to numerator, it will become minus 3.5 into minus f, that is f2 equal to 3.5 f. Now what is the sign we are getting here? Plus. It means what? If you got any lens, if it is kept in a medium which has got refractive index more than refractive index of this, then its nature will be changed. So here will behave as what? Convex lens or converging lens. That is lens, concave lens behave as, right on here, that is here concave lens behave as a converging lens of focal length 3.5 times of initial focal length. Now let us go for other thing. Now let us say that a hollow equiconvex lens of glass will behave as a glass plate justify. Well, now we'll consider the hollow equiconvex lens. Suppose say this is a hollow equiconvex lens. If we break into two parts, what we will have here? It is hollow, so what should happen? We should be getting here portion like this. If we cut it in this manner, what we will have? We will have one lens of this type and other lens of this type. So when we cut like this, we will be getting in this manner. Now here, since it is a thin one, so hollow equiconvex lens is there. Assume that this curvature is thin. So what should happen? Value of R1, value of R2, both will be same. Here also value of R1, value of R2, both will be same. We will consider this one as R1 dash, R2 dash. Now your ray will be incident like this. R1 and R2 both are on that side. So we get it on R1 equal to R2 equal to R. R for it plus R. And we'll find out F1. Or we'll find out F1 for this particular lens, first lens. Then for second one, R1 dash, R2 dash should be how much? Both should be minus. Here ray is incident like this. Both will be having curvature in this side. So both will be having minus sign. F2 is how much? We'll find out. Then we can go for relation of effective focal length of it. So focal length of this we are taking as F2, this as F1, and this as F. Now for first surface, we get it on 1 by F1 equal to n minus 1 into 1 by R1 minus 1 by R2. 1 by F1 is equal to, this will not change, n minus 1 will remain same, R1 is R and R2 is also positive R. So what happens? These two cancels. We get 1 by F1 equal to 0. So F1 equal to we get as 1 by 0. That is what? Infinity. Now for second phase, for second surface, we get on F2, 1 by F2 equal to n minus 1, 1 by R1 dash minus 1 by R2 dash. So 1 by F2 equal to, we get on n minus 1, 1 by minus R minus 1 by minus R. 1 by minus R, again both will cancel. So actually it will become plus and minus cancel. We get it on n minus 1 into 0, that is 0. So again F2 also become how much? Infinity. And we know 1 by F1, 1 by F equal to 1 by F1 plus 1 by F2 because they are placed in contact. 1 by F equal to 1 by infinity plus 1 by infinity. So it will become 0 plus 0 or F equal to 1 divided by 0. That is nothing but infinity. And as it is infinity, what you will find that they will be behaving like what? A glass plate. So they behave like a glass plate. A glass plate. Now, next question. The wavelength of light in vacuum is lambda naught. First off, when it travels normally through glass of thickness T, comma, then find the number of waves waves of light, light in T thickness, T thickness of glass, T thickness of glass, refractive index, is mentioned to be mu. Mu is the refractive index of it. Now we know that suppose say we have got this as a wave. This distance we call it as wavelength lambda. That is called as wavelength lambda. Now assume that we have got like this a glass slab is present. Glass slab is present. Then we can write it here. This will be 1 lambda, 2 lambda, so on, so on. It means thickness can be written as T equal to n into lambda. Lambda where? In the medium. Lambda in the medium. So now we will use the formula number n is equal to thickness divided by wavelength. Thickness by wavelength from this concept. Now n equal to thickness is T, wavelength in the medium. Well, wavelength is given in air to be as lambda naught. Air, it is given to be vacuum or air. Its vacuum is mentioned. So in vacuum or air, it is how much? Lambda naught. So we can write on this as T by lambda m. But we know refractive index is equal to lambda in air by lambda in medium. So lambda in air is lambda naught. If you use this relation, it will become n equal to T into lambda m is down. We can write down lambda m equal to mu lambda naught divided by mu. So here lambda m is equal to lambda naught divided by mu. Well, see me. Here it should be reversed. Lambda m is equal to lambda naught by mu. So T in mu divided by lambda naught will be the answer. So in the place of lambda m, we are writing lambda naught by mu. So mu go to numerator and lambda naught will be obtained in the denominator. Now let's go for next question. The refractive index of the refractive index of a prism is 2. A prism is 2. This prism can have maximum refracting angle dash dash. Maximum refracting angle dash dash. Now we know that suppose say we have got a prism with us, and if a ray of light is incident at one particular angle, well, incident normally on one face, and if it falls at a particular angle on the opposite face, then what will happen? It will just graze the surface. If the angle of incidence is slightly greater, then it undergoes total internal reflection. So now this angle we can take it as C critical angle, and we know if this angle is A, by symmetry of the triangle it is 90 degree. So what should happen? It will be say something like theta. Then this angle plus theta should be equal to 90. So this angle plus this angle, sum should be how much? The sum of this angle and this angle. So what should happen? A will be equal to C. Now here refractive index is given, that is mu is equal to 2 is given to us. Asked to calculate what is the value of A here, and we know that n is equal to 1 by sin C is the formula we will be having. We get it on sin C is equal to 1 divided by n. Sin of C, C is what? Angle of the prism is equal to 1 by 2. A will be how much? Sin inverse of 1 by 2, that is nothing but A equal to 30 degree will be the answer. Now next one, for a equilateral prism, for a equilateral prism, it is observed that it is observed that when a ray strikes grazingly at one face, it emerges grazingly at the other face, full stop. Its refractive index will be, its refractive index will be is asked. Now will be, we can write down here dash dash. Now what is given here? That suppose say this is the prism we have. On this prism, say it is normal, a ray is incident at some angle over here. Say, well, grazingly is mentioned. Grazing means what? The ray should be incident like this, brushing the surface. So this angle of incidence can be taken as how much? 90 degree. So because it is mentioned grazingly one face it is incident. After refraction, say travels like this, then one more thing is mentioned, it emerges grazingly at the other face. So it means what? This ray which is incident like this, coming out in this manner. Now I2 will be how much? I2 will be equal to again 90 degree. Here this angle say is A. It is mentioned it is a equilateral prism, so it will be how much? 60 degree. If we take this one as angle of refraction R1, angle of refraction R2 as a second one. Asked to find out what is the refractive index, means n equal to how much. And now we know this one, that when I1 equal to I2, here it is mentioned 90 degree, then what should happen? For this particular thing, R1, R2 also must be equal to R. We know one more thing that A equal to R1 plus R2. R1 plus R2 equal to angle of the prism. So it will become R plus R equal to 60 degree. That is 2R equal to 60 degree. So R equal to how much? 30 degree. We know that N equal to sine of I by sine of R. N equal to sine I by sine R, that is refractive index of the prism, N. Now I is mentioned, we can take any one I1, I2, any one I. So it will become sine of 90 divided by sine of 30. Sine 90 is 1, sine 30 is 1 by 2. So refractive index will be how much? 2. N will be equal to 2. Now, let us see next one, a thin prism of 4 degree angle gives a deviation of 2.4 degree. The value of refractive index, of the material of the prism is well, now it is a thin prism, and we know that in thin prism D is given by A n minus 1. What is asked here in this first given thing is angle of the prism is 4 degree. So we get it on A equal to 4 degree. Deviation produced is 2.4 degree. So deviation is 2.4 degree. Asked to find out refractive index means N equal to how much? N equal to how much? Now we know that D is 2.4, A is 4 degree, N minus 1. Now it is also degree cancels. 2.4 divided by 4 equal to N minus 1. We'll get, we get it on 1 plus 0.6 equal to N equal to 1.6. This will be the answer. Now coming to next one. Well, given that a ray of light incident on an equilateral prism shows a minimum deviation of 30 degree. Minimum deviation of 30 degree. The speed of light, through the prism, through the material of the prism, the material of the prism is is? Well, a ray of light is incident on an equilateral prism. Well, when equilateral prism is given, it means all the three angles of the prism will be same, and here we can take directly as what? A equal to 60 degree. Now, the minimum deviation is 30 degree, so that is we get on D is equal to 30 degree. The speed of light through the material of the prism, we know outside the medium it is C. C value is how much? 3 into 10 power 8. C equal to 3 into 10 power 8 meter per second. In the medium, we'll take that one as V. So say V is the speed of light in the medium, V is asked. Now, we know that N equal to sine of A plus D divided by 2, otherwise we will write down capital D here because the same symbol we had used, capital D, minimum deviation. This will become sine of A by 2. It is one relation, and second one, refractive index is given by C divided by V. We will equate the two, it will become sine of A plus D by 2 whole divided by sine of A by 2 equal to C divided by V. We will first put the values, it will become sine of 60 plus 30 divided by 2 whole divided by sine of 60 divided by 2 equal to 3 10 power 8 divided by V. 3 10 power 8 by V. Now, 60 plus 30, 90. 90 by 2 is 45. Equal to sine of 45 divided by sine of, it will become 30. 30. 60 divided by 2, 30 degree is equal to 3 10 power 8 divided by V. Now, we will take this one here, means cross multiply. So, we get 3 10 power 8 into sine 30 divided by sine 45. V equal to 3 into 10 power 8 into sine 30 is 1 by 2, sine 45 is 1 by root 2. 1 by root 2. This can be written as 3 into 10 power 8 into root 2 divided by 2. Now, we will first multiply this 3 into 1.414 10 power 8 divided by 2. So, 3 4 ja 12, 3 1 ja 3 plus 4, 3 4 ja 12, 3 4, so point into 10 power 8 divided by 2, it will become 2.121 10 power 8 meter per second. 2.121 10 power 8 meter per second. Now, let us go for other question. A thin prism P1, a thin prism P1 of angle 4 degree and refractive index R dot I dot, refractive index 1.54 is combined with another thin prism, another thin prism P2 of refractive index 1.72 to produce dispersion without deviation, dispersion without deviation. The angle of P2 is the angle of P2 is. Now, what's given? A thin prism P1 of angle. We'll take this one as A equal to 4 degree. First prism's angle. Refractive index will be done as N equal to 1.54. Combined with another prism P2 of refractive index will be done as N dash 1.72. To produce dispersion without deviation, it means dispersion without deviation. The angle of the prism, when second angle is asked for it. We know that in dispersion without deviation, we have got condition as an minus 1 by n dash minus 1 the angle of second prism. So this can be written as A dash equal to A is 4 degree, N is 1.54 minus 1 divided by 1.72 minus 1. Now, this will become A dash equal to minus 4 degree into 0.54 divided by 0.72. Now, here remove the decimal points, then 2 will cut by 2, 2 3 ja 6, 2 6 ja 12, 2 ja 2 7 ja. We can cut this by 9, 9 4 ja 36, 9 3 ja 27, 4 cuts, we get A dash equal to minus 3 degree will be the angle. Minus 3 degree means what? If one prism is arranged like this, whose angle is here, second should be arranged in the inverted position like this. So this minus sign indicates that angular prism of the second prism is in the opposite direction of that of the first prism. Now, dispersive power of the material of a prism is 0.0221 is the deviation produced by it for yellow color is 38 degree, then the angular dispersion between red and violet colors is dash. Now, what is given? Dispersive power is mentioned, means omega 0.0221. If the deviation for yellow, deviation means D for yellow is equal to 38 degree, 38 degree D yellow. What is asked? Then the angular dispersion for the violet and red means dV minus dr equal to how much? We know that omega equal to dV minus dr divided by d for mean, that is this. So dV minus dr can be written as omega into dy. Omega into dy. Omega is 0.0221 into 38. Now we have to multiply this 0.0221 38. 8 1 ja 8, 8 2 ja 16, 1 16 1 17, 3 1 ja 3, 3 2 ja 6, 3 2 ja 6, 8 9 13 1 8. 8 since it is in degrees, we get on 8 3 9 8, 4 digits we have to leave like this degree, that is 0.84 degree will be the angular dispersion for it. Now so here today we will stop. Tomorrow we will continue with other things, means in the next class we will continue with other things. Thank you.